All right, let's talk about debugging. If you're a programmer, you're gonna be debugging. It's just part of the job. But what if you stopped thinking of it as this awful chore and started treating it like a skill you can actually get good at? Today, we're gonna build your debugging toolbox so you can hunt down and squash those bugs with real confidence. Oh, you know the feeling. We've all been there. Your code is doing something weird, something totally unexpected, and you have absolutely no idea why. It is without a doubt one of the most frustrating things about programming. You're just staring at the screen, and you can feel the bug just staring right back at you. So today, we are done with just staring at the screen hoping for a miracle. We're going to systematically upgrade your debugging toolkit. We'll start with the tool everyone knows, the simple print statement, and then build all the way up to some professional techniques that are going to save you hours of headaches. Let's get into it. Okay, let's start with our very first tool, the one everybody knows, the humble print statement. You can think of this as your magnifying glass. It's super simple, it's quick, and it's perfect when you just want to get a close look at one variable at one specific moment. But, and this is a big but, there's a smart way to use it, and then there's the way that just adds more confusion. So, look, just printing out a number like 416 doesn't really tell you much, does it? We can make our magnifying glass way more powerful by giving it context. By using something like the dot format method, you add a whole descriptive message. Now, the output isn't just a random number. Right away, you see the problem. The output screams, hey, I just set x to 416, but it's not supposed to go over 400. Bam, you're on the trail of the bug. But you know what happens. As your project grows, that trusty magnifying glass starts to create its own set of problems. All your helpful little debug messages get totally jumbled up with your program's real output. There's no big off switch for all your print statements, and when you think you're done, you have to go on this annoying scavenger hunt trying to find and rip them all out. This is where we need a better tool. So let's move on to our next tool, logging. If print is our quick and dirty magnifying glass, our next tool, logging, is like a professional, super organized lab notebook. It lets you write down all the detailed notes you want about what your program is doing, but without making a mess of the final result. And you might think this sounds complicated, but getting started is actually dead simple. It's really just 3 steps. First, you import the logging library. Second, you configure it. You just tell it, hey, I want you to save all the notes to this file, and I want you to capture all the debug level details. And third, you just go through your code and replace your prints with logging.debug. And just look at the result. The code on the left, it runs totally clean. No extra stuff clutters up the output. But over on the right, in our special debug.log file, we get this beautiful, separate, time-stamped record of everything that happened behind the scenes. And here's the magic trick. When you're done, you can turn off all these messages with just one tiny change to the configuration. No more scavenger hunt? All right, our next tool is a bit different. It's not about watching your code, it's about policing it. While print and logging help us observe what's happening, the assert statement is more like a guardrail. It actively enforces the rules of your program and slams on the brakes if one of those fundamental rules gets broken. It's basically a sanity check. Now, here's the key idea you really need to get about assertions. They are there to check for things that should be absolutely, positively impossible. We're talking about catching programmer errors, moments where the internal logic of your program has gone completely off the rails. The job of an assert is to fail, and to fail loudly and immediately. And hey, little pro tip for you, these assertions are usually turned off in production code, so they don't slow things down. They're purely a tool for you, the developer. Okay, let's see this in action. We've got this function that converts Kelvin to Fahrenheit. Now, a law of physics says the temperature cannot go below absolute 0 Kelvin. That's a rule that should never be broken. So we put an assert statement right at the top as a guard. Here we're passing in a totally valid temperature, 273 Kelvin. The assertion checks out, it's true, so the function just runs perfectly, no problem. But what if some other part of our program has a bug? What if it accidentally calculates a negative temperature and passes that impossible value into our function? What happens when our sanity check actually fails? This is what happens. Boom, the program crashes instantly with an assertion error, and look at that fantastic, clear message, colder than absolute 0. It stops everything right at the source of the problem, before that bad data can spread and cause more chaos. This is so much better than letting your program continue running with bad data, only to have it crash for some mysterious reason 5 minutes later. And this brings us to a really important distinction you gotta understand. So, bottom line, you use assert to catch your own mistakes, bugs in your own logic. things that should never, ever happen. You use try/accept, on the other hand, for stuff you expect might go wrong with the outside world, like a user typing in text when you asked for a number, or a network connection dropping. One is for flagging your bugs, the other is for handling the messy, unpredictable world gracefully. Okay, we've had a magnifying glass, a lab notebook, and some guardrails. Now it's time to bring out the heavy machinery. Let's talk about the absolute power tool in our toolbox, the breakpoint.
Forget just printing out one value at a time. What if you could literally hit a pause button on reality inside your code? What if you could just freeze time at any given line, pop the hood, and look at the value of every single variable at that exact moment? Well, that's exactly what a breakpoint does. It's basically a time machine for your code.
And it's so easy to do. You just click in the margin of your editor, see that little red dot? That's it. That's your breakpoint. Now, when you run your code in debug mode, it'll execute as normal right up until it hits that line. And then everything just freezes. Then you just look down in your debug window and it's all there. The state of every object, the current values of X and Y, everything is laid out for you to inspect. This is hands down the ultimate way to see what your code is really doing. So there you have it. We've gone from just one simple tool to an entire professional-grade toolbox. Now you've got a whole range of strategies to pull from the next time one of those mysterious, inevitable bugs shows up. So let's do a quick inventory of our awesome new toolbox. You've got your print function, that's your quick magnifying glass. You've got logging, that's your organized lab notebook for taking clean notes. You have assert, your strict guardrails to make sure your code never goes into an impossible state. And finally, you have breakpoints, the time machine that lets you pause everything and see it all. You are now officially equipped to tackle bugs with confidence. So the next time you're stuck on a tricky problem, don't just stare at it. Open up that toolbox, pick the right tool for the job, and start solving that puzzle. Happy debugging!